Hey, it's T. I'm one of the geniuses at Ask Zylor. So let's just get started with the live session.
So the first question we'll be dealing with is a grade 11 functions question. So it's dealing with special triangles. So we're told that 5-meter ladder is propped against a classroom wall. It forms an angle of 30 degrees with the wall. Exactly how far is the top of the ladder from the floor? Express your answer in radical form. So let's draw a brief diagram just to show what we're dealing with. So this ladder is 5 meters and it makes an angle of 30 degrees. So this is a right angle triangle. So what assumptions did we make? We're going to say this is the distance from the bottom of the ladder to the wall. So they asked me exactly how far is the top of the ladder from the floor, so we can get the height essentially. Right? So we can write an equation dealing with the height and the 5 meters. So it's going to be opposite of a hypotenuse. So I have sine of 30 degrees is equal to opposite, which is height, over 5 meters. So we're asked to find what this height is. So my height is going to be sine 30 degrees times 5 meters. Right? We can use special triangles to solve this because we know what the 30 degrees is. So my special triangle is going to look something like this. So I have 1 square root 3 and 2. So my sine of 30 degrees is going to be 1 over 2. So that is what I'll be substituting instead of sine 30 into my equation. So I have height is equal to 1 over 2 times 5. Right? So my height would end up being 5 over 2. Okay, so we'll move on to the next question. So this is a question dealing with just the perimeter of a complex shape. So they asked to find the total perimeter. So what we can do is simplify this problem a little bit, because this distance and this distance is the same as this distance plus this distance. Right? So we know the total distance to be 15.7 plus 3, 6. So I'm going to add that up. So I'm going to say 15 feet 7 inches plus 3 feet 6 inches. I can add them up to be 18. And this is 13 inches. So I'm going to convert the 13 to be 19 feet and 1 inch. So I'm going to label this as my width. So my width is 19 feet and 1 inch, and I'll call this distance my length. So once again, we can simplify this because this length, and this length all add up to my total, which is 38 feet and 6 inches. So my length is 38 feet and 6 inches. So I have 2 widths and 2 lengths, so I'm simply going to multiply each one of these by 2. So length times 2, added up to my width times 2. So I have 38 feet and 6 inches times 2 plus 19 feet and 1 inch times 2. Right. So 38 and 19, they both add up to 114 feet. And the 6 and the 1 add up to 14 inches. So I'm going to convert this again to feet. So I have 15 feet and 2 inches. Okay, so we're going to move on to the next question. Once again, if you have questions about this or if you want something explained in more detail, send us a message. We'll try our best to accommodate all the questions. So the next question is dealing with a grade 9 math question. It's dealing with rates of change. So we'll be just doing 1A and 3A. So for 1A, they're asking you, look at the patterns given below. What's the rate of change, initial value, and equation? So if we're looking at this question, let me just zoom into this. My initial amount is if I look at the number, it's just 3 blocks. I have 1, 2, 3, right? And in my second pattern, I have 6, and in my third, I have 9, and then I have 12. Okay, so what's changing between each of these is the value 3. Right, so I'm adding 3 blocks every time. So that's my change, my rate of change. What's my initial amount is what I have initially in my first pattern, which is just 3. So I can write an equation for this. So I'm going to say my initial amount is 3, my change is 3, and then I can have an equation that describes the initial and the change using n as the figure number. So I have figure 1, 2, 3, and 4. So I'll say n is my figure number. So I have initial amount of 3, and I'm increasing by 3 every single time and changing my figure number. So I have 3 plus 3n. So that's how I get the equation. I find out how much do I have initially, how much am I changing by, and if what I'm changing by, I'm going to multiply by my figure number. So the third question is talking about given table of values below, find the rate of change, fill in the missing parts of the table, find the initial value, find the equation. Okay, so we're given x, y table, so let me zoom into this. Okay, so what we can do is figure out the slope for this using these 2 points. Okay, so the slope I know has the equation y2 minus y1 over x2 minus x1. Right, so my y2 would be 26 minus 8 over 4 minus 1. So my slope ends up being just 6, so because 26 minus 8 ends up being 18, 18 over 3 is going to give me 6. So that's my slope. Right. What can I do with the slope? I can figure out how much is it changing from every value from my y. So to go from 8 to the next point, I'm going to add 6. Right, and so on. So I have 14. And then I'm going to add 6 to that, so I have 20. And then I'm going to add 6 to the 26, so I have 32. Right? But to go backwards, I'm just going to subtract 6 from my 8 to give me 2. So that's how I fill in the values. So the next part is to find the rate of change. I found my rate of change, which is the same as my slope. So my rate is just going to be 6. What's my initial amount? Is when my x is equal to 0. So my initial is going to be 2. Find the missing parts of the table. We've done that. And find an equation. So I'm going to say y is equal to what's my rate, x, how much am I changing by, depends on my x, plus my initial amount, so plus 2. So this is my equation. So this is a factoring question, so it could be relating to grade 10s and grade 11s. So when we're given 4 terms, we should always be trying to factor out any common terms before we even try to factor by grouping. So if we can't find any common terms, that's when we get to the grouping. So what we do is we try to group 2 terms together which have common terms. If I pick the first 2 and the last 2, the first 2 don't really have any common terms, and the last 2, they have a common term of b. But what I should notice is if I group the first 2 and the last 2, this first grouping gives me a difference of squares. So let's see what we can do with that. So I have 4a squared minus 9 minus 2ab plus 3b. Right, so if I do difference of squares, I get 2a minus 3 and 2a plus 3. All this minus 2ab. Now, from the minus 2ab plus 3b, I can group them together and factor out the common term, which is the b. So I'm going to factor out a b, leaving me with 2a plus 3. Now notice how we have the same terms on both the groupings, so I can factor the 2a plus 3 out from both my terms. So I get 2a plus 3, and inside I have 2a minus 3 minus b. Right, so whenever we do factoring, always try to find patterns like difference of squares, perfect trinomials, and so forth. So we'll do another question. So in this case, we have a more complicated problem because we have x squared plus 3x, all of that is going to be squared. Okay. What we should notice is that the first term is the square of my second term. It's the same as if I had x squared minus 2x minus 8. Why? Because when I factor this, I can replace these values with the x squared plus 3x, whatever was inside. So I'm going to just do substitution to be y is equal to x squared plus 3x, and I'm going to replace each of the x squared plus 3x with my y. So this gives me y squared minus 2y minus 8. Now this I can factor. Right, so how do I factor this? I'm going to look at my constant, so negative 8. What are factors for my constant? That give me negative 2, which give me the difference of negative 2. Right, so I have 1 and 8. I have 4 and 2. 4 and 2, the difference is 2, so I'm going to use that. So I have y minus 4, y plus 4 plus 2, as my factors. So once I'm done, what I can do is replace my y's with what I had initially, which was the x squared plus 3x. So I'm going to replace each of the y's with x squared plus 3x minus the 4, and then x squared plus 3x plus 2. Right? We shouldn't be satisfied with just this because these are, again, quadratic equations that we can factor. So the x squared plus 3x minus 4, I can factor to be x minus 4, x plus 4, x minus 1, and then this one would be x plus 2, x plus 1. This is my final answer. So let's move on to the next one. So this is a grade 12 calculus and vectors questions. It's dealing with optimization. So we're told only 2700 centimeter squared of material is available to make a box with a square base and an open top. Find the maximum volume of the box. So with optimization, what we try to do is find two equations and relate them to each other. Right? So we're trying to find the maximum volume. So that means we need to find a volume equation in terms of one variable and try to maximize that. So in other words, find the derivative, make that equal to 0, and solve for the variable. Right? So let's start with what they've given us. They said only 2700 centimeters squared of material is available. So it's got a square base and an open top. So let's just draw a brief picture of this. Right. So the top is open, the rest of the sides need to be covered. So I'm going to say this is my length, this is my width, and this is my height. So since it's a square base, my length and width are the same. So I'm going to say my length is equal to x. So I have my width is also equal to x. Right. So if I use an equation for the surface area, I have length times width, and then I have 2 length times height plus 2 length times height, 2 width times height. Right? Because we have one side which is length times height, and we have one side with width times height, and we have another with length times height and another with width times height. And we have the bottom base, which is just length times width. right? So what we do at this point is substitute the surface area because they've given us a value for that. So I'm going to substitute the 2700 over here. And I'm going to replace the length and width with my x's. So I have x squared plus 2x height plus 2x height. So I can simplify this to be 2700 is equal to x squared plus 4xh. Right? If I wanted height in terms of x, I can say height is equal to 2700 minus x squared over 4x. Right? So my x, it can't be 0, because if it's 0 then I have an undefined number, so my x has to be greater than 0 and less than the square root of 2700, because if it's greater than that, it's going to give me a negative answer and I can't have a negative dimension. Right, so I'm going to write an equation for my volume at this point. So volume is length times width times height. My length and width are x's, so I'm going to say x times x is x squared, and my height I'm going to say is this. So I'm going to say 2700 minus x squared over 4x. Okay, and at this point I'm going to simplify by cancelling out the x over here and one of the x's on the top. So this leaves me with x times 2700 minus x squared over 4. Then I'm just going to expand to give me a nice equation. So I have 2700 over 4 to give me 675x minus I have x cubed over 4. So this is an equation for my volume in terms of just one variable, which is x. My x could be my length and width at this point, right? So now we've got to this point, what we should be doing is find the derivative of my volume to find the maximum volume, right? Because the question was telling me find the maximum volume of the box given these conditions. So to find the maximum volume, I'm going to differentiate this equation. This gives me 675. That's going to be minus 3x squared over 4. I'm going to make that, set that equal to 0 and solve for my x. Negative 3x squared over 4. So my x squared is equal to 4 times 675 over 3. And then I'm going to square root both sides to find an x value. So when I plug this into the calculator, I should get plus minus 30, right? We don't really care about the minus 1, so because I can't have a negative dimension, so I'm just going to say x is equal to 30 centimeters. So what we found is the maximum volume is when x is equal to 30. Right? We also know x is the same as width and length. So my width and length for my dimensions for the box have 30 centimeters as the length and width. What I'm going to do next is they ask me to find the maximum volume, right? So they're not asking me for the dimensions. So what I'm going to do is take this 30 and plug it back into my volume equation, which was originally back here before we differentiated it. Right. So I'm going to check when x is equal to 30. I'm also checking the endpoints because I gave myself a range because x can't be less than 0 and x can be greater than the square root of 2700. Right. So I'm going to plug those in as well. So x is equal to 0 and x is equal to square root of 2700. So x of 30 gives me 13,500 centimeter cubes. I'm just skipping some steps just to save time. And at 0 it's going to be just 0, and at square root of 2700 I get 0 as well. So my maximum volume happens when x is equal to 30. So I can also state the dimensions of the box. So the dimensions of the box, I have my width is 30 centimeters, my length is 30 centimeters, my height on the other hand, I need to find, I can plug it into the height equation that I came up with earlier. Right? My height was 2700 minus x squared over 4x. So I'm going to plug in 30 for all my x's, and that's going to give me a height of 15 centimeters. So the maximum volume is going to be when my width is 30 centimeters, my length is 30 centimeters, and my height is 15 centimeters. Okay, so we'll move on to the next question. So this is where we're going to grade 9. We're talking about parallel lines. So we're given two equations. So find the equation of a line that's parallel to y is equal to negative x plus 5. So it's parallel to this line, has the same x-intercept as this 3x plus 2y minus 18. Right? So if we have an equation y minus 2x plus 5, if a line is parallel to this, that tells me that the slopes are the same. So my slope for my new line is also negative 2. Now it's telling me it has the same x-intercept as 3x plus 2y minus 18. So I'm going to rewrite that 3x plus 2y minus 18 is equal to 0. So x-intercept is when y is equal to 0. Right? So I can find the x-intercept by plugging in 0 for my y. So I have 3x plus 0 minus 18 is equal to 0. So my 3x is equal to positive 18, and then my x is equal to 6. I divide both sides by 3. So I found the x-intercept. So what that tells me is my equation also has an x-intercept at the same point. So I have a coordinate. I have 6 and 0. Right? So if I try to make an equation y is equal to mx plus b, for the new line my slope is the same as the previous one, which is negative 2. So I'm going to say y is equal to negative 2x plus b. To find my b value, I'm going to substitute this point in. So I'm going to say 0 is equal to negative 2 times 6 plus b. Right? So my b is equal to 12. So my final answer is going to be y is equal to negative 2x plus 12. Okay, so we'll move on to the next one. So this is a grade 11 functions question. So we're dealing with quadratic applications. So we're told the rectangular park has an area of 575 meters squared. The park is to be surrounded by a walkway that is the same width on all sides of the park. The park and the walkway together are to measure a certain to measure 30 centimeters by 27 centimeters. So let's draw a brief diagram just to describe what we're dealing with. So this is the rectangular park. So we're surrounding that with a walkway that's the same width on all sides. So this width is the same as this width. The park and the walkway together are to measure 30 centimeters. So let's say this is 30 centimeters by 24 centimeters. Determine the width of the walkway. So I'm going to say the width of the walkway is x. Right? So what we have to do initially is write an equation for the area. So the area initially is 30 minus 2x times 24 minus 2x. My area for the park, which is just this, right? So to get just the width and the length, I'm going to take 30 centimeters and minus the 2x because I have x on both sides of my length and width. So I'm going to substitute the area that's given to me for the area of the park to be 575. and I'm going to expand these two brackets. It gives me 4x squared minus 108x plus 720. So we need to find x essentially, and we're given this equation. So what we should be doing is making this equation equal to 0 and solve for the x values. So if I bring the 575 to the other side, and I'm left with 0 is equal to 4x squared minus 108x plus 145. Now the equation in this form should remind you that the 0 tells me my y is equal to 0. Right? If my y is equal to 0, that means any x value I get would be my x-intercepts. Right? So how do I find the x-intercepts? I need to find the factors, or the factored form of this equation. So I'm going to try and factor it. If I can't factor it, what I'm going to do is put it into my quadratic equation. Right? What's my quadratic equation? My quadratic formula, it's minus b plus minus square root b squared minus 4ac over 2a. Right? My b is negative 108, my a is 4, my c is 145. So I'm going to plug all that in, and I'm going to get x is equal to 1.417, or I get x is equal to 25.83. Can my x be this big? No, because the maximum length is just 30. Right, so my x can't be bigger than one of the widths, one of the sides of the dimensions of the park itself. So I'm not going to account for that, and I'm only going to say the width is going to be 1.417 meters. So that about does it for me today. So just a quick update, the next live will be on Monday. So if you want your questions answered, please send them in then. So thank you for tuning in. Hope you guys have a great night. And this has been T from Ask Zylor. Have a good night.